Extreme Steam Team.
Hello everyone, thanks for joining our Extreme Steam Team. I want all of you to meet my friend Ophelia the Ostrich. Say hi, Ophelia.
Hello. Charmed to meet you all. What are we learning about today, Jurassic Jessica, my dear?
Well, today is all about flight, which is funny because ostriches can't fly.
Oh, how rude! I don't mention your shortcomings, Jessica, my dear. It is as you young ones say, quite a drag.
Speaking of drag is a really important part of what we're discussing today. Aerodynamics.
Who's the what?
Aerodynamics. It's the study of how air moves around an object, like an airplane. Our friend Petrie just interviewed a pilot from Ocala Aviation. Let's go to the dish with Petrie to see what they learned today about aerodynamics and flying airplanes.
Indeed, darling.
Hello, kids! Welcome to the Dish with Petrie, and I'm your host, Petrie. Yay! All right. Today we will be having a special guest who makes a living in the skies. Let's check the Petrie scope right now. Beep boop, beep beep boop. Wow, it's Captain Adam from the Ocala Aviation Flight School. Hello, Captain Adam.
Hey guys, Petrie, hi, how you doing?
I'm good, and how are you?
I'm great. A little rainy today, but that's okay.
Yeah, I'm loving that plane you have right there.
Yeah, this is a big one here, a little fun model airplane that I like to display just to make things interesting in the office.
Yeah, looks so cool. So, I am told you're a pilot over there.
That's correct. I'm a commercial pilot with what we call an instrument rating to be able to fly through the clouds. And I also teach people to fly. I'm a certified flight instructor, or what we go by with acronyms, CFI.
Wow, you're a certified flight instructor. That is so cool. Wow. So, how does one become a pilot?
Well, it definitely takes a certain amount of time and a little mindset towards getting educated on certain things like the weather, hand-eye coordination with the skills of manipulating the airplane with the controls, getting used to doing some of the maneuvers while flying, and also really getting to know the aircraft itself. For example, some of the systems, the mechanisms, what all the buttons do, for example. And as you train to learn all those things, we basically take about 40 hours in total to get you as complete as we can and educated enough aeronautical knowledge-wise to be able to take a check ride, kind of like a driver's test, but in the sky.
Wow, a driver's ed test in the sky.
Yeah.
That's so amazing.
Pretty cool.
Yeah, so you think I can become a pilot too?
I think so, Petrie. I think if you're willing to put in some hard work, kind of grind at getting to know the aeronautical knowledge, which is fun in itself, learning some of the lingo, and you speak pretty well, so I'm sure talking on the radios to air traffic control would be easy for you. But I think you could do it overall, buddy.
All right, I'm gonna be a pilot one day. Yay! Okay, so I've been meaning to ask you. I know planes are made of metal. So how is it that something that's heavy can stay in the air?
That's a great question, because at certain times we see some aircraft that are so big, for example, like my 747 model here, which is one of the largest airplanes for when its time came out, you think to yourself, how could something that heavy be able to get in the sky and fly? Well, a big part of that is how we think about the four forces of flight, four things that act on an airplane scientifically: lift, weight, thrust, and drag. You mentioned weight with how heavy the aircraft is, but if we can create enough thrust to move ourselves forward, we can get enough air to move over our wings to be able to change a pressure and be able to get us to create lift, which can overcome that weight and let us fly.
Hold on, that like flew by me real quick. Can we just break it down to some of the principles?
Absolutely. If we think about it like this, air has pressure, and good thing it does, because it helps with us breathing when it comes to taking an inhale of oxygen and exhaling carbon dioxide. Well, the idea is that with air, our atmosphere, having pressure, we've actually found through science that the wing of an aircraft actually has a specific airfoil shape where it's curved on top, still flat on the bottom in some cases, to where we actually have a pressure change. Due to that curved surface, the air molecules will speed up on the upper surface of that wing. And by doing so, they become a lower pressure, which creates something of like a suction effect that is something that helps with the creation of lift. We call that Bernoulli's principle. That's an old scientist that was able to do that with the change in the flow of water through pipes and being able to see the same circumstances happen with water, because water flows a lot like air.
So, lift, weight, thrust, and what was the last one again?
The last one, we use a joke here where we say, oh man, drag. It's such a drag, man. Drag is what we consider to be the opposing force to thrust. Bottom line is thrust, we want to go forward, and we want to go forward fast. We know we want to do that with airplanes so we can get where we're going fairly quick. But the idea is that anytime we create lift, we create this drag. And the drag is really just something that exists to slow us down. But in the idea of what we're thinking with the airplane and four forces acting on it, and one of them being drag, we know we can compensate for certain things that we can use drag to our advantage, like when we're coming into land, as far as helping us slow the airplane down and reduce our descent rate to be able to come from altitudes that are high up to then come into altitudes that are lower to then eventually be on the pavement of the runway. But the idea of drag from where it's created from lift, we call induced drag. So if we talk about lift, we have to talk about drag, because that's what we call a byproduct of lift.
Wow, so it's like a balance of all the four principles to make the plane fly.
You got it. And there is actually a time when they're all equal, or what we call in equilibrium. I like that word because it's just kind of fancy to say, equilibrium. But the idea of lift, weight, thrust, and drag are all in equilibrium when we are in straight and level, unaccelerated, or go faster flight.
Wow, let me say that word, equilibrium.
Pretty
Wow.
close, man, pretty close.
That's so cool. So I want to ask something that's like closer to the ground, if that's okay.
Absolutely, Petrie.
All right, so how can planes land on water?
Great question. We know that most aircraft that we're describing even right now, we know have giant tires that are basically going to roll on pavement. But there is another category of aircraft that we call seaplanes. And I don't have my seaplane rating yet. However, that is one of the things I look forward to getting here soon. The idea of being able to have an airplane float has to do a lot with what we call pontoons. Instead of having tires, we have giant, almost canoe-shaped type of hollow pontoons or materials made of metal that actually attach to the bottom of the aircraft, and they're large enough to support the weight of the aircraft while being on the surface of the water. And while doing so, they're able to have it float just like a boat. I rhyme.
Wow. That is so cool.
Pretty neat.
And I've seen on TV that planes can also land on boats.
Yes, that's a good one there too. When we think about something like that, I think of, well, our military, especially the Navy. We have what we call aircraft carriers, giant boats that hold, well, a lot of military aircraft. And at certain places around the world where they're serving and protecting our freedom, they actually have airplanes that need a runway. And on that surface of the ship, they have those. And those aircraft are able to, with a giant tail hook and huge strong cables, are able to, with just like pavement, have tires. But when they come into land, they'll land on the boat, and the little tail hook will snag the cables to make sure they don't go off the end. And you guessed it, they're landing a regular airplane or military jet on an aircraft carrier on open water on a boat. Pretty cool.
Wow, it is pretty cool.
Yeah.
It's like planes can fly anywhere and land everywhere. So
Pretty
it's-
close.
Yeah, so it's getting me to thinking, can we fly to the moon?
You know, we have flown to the moon, Petrie, obviously with the rocket ships we had in, well, 1969 with Apollo 11 and everything there that came after. But if you're thinking that an airplane will get you to the moon, no, that's a little bit mistaken. The idea of using airplanes in our atmosphere has a lot to do with the lift that I talked about, using the air molecules over the wing or airfoil shape. But if you're talking about going to the moon, we need a lot of thrust, so much thrust, several thousand pounds of thrust, that we can actually escape the Earth's gravity. When we talk about the airplane having weight, well, remember, the weight of the airplane is pulled to the center of the Earth because of gravity. So if we want to go to the moon, we've got to escape that gravitational pull of the Earth. And by doing so, we got to go fast, super fast, like thousands of miles per hour fast, which they can do, and they have done here lately, especially nearby at the Space Coast near Cocoa Beach with the Kennedy Space Center, launching rockets, which are going up to the International Space Station right now. But back in the late 60s and early 70s, they were fast enough and strong enough to escape the Earth's gravitational pull and go all the way to the moon.
Wow, to the moon.
To the moon.
Cool.
And if you're wondering, Petrie, the moon is not made of cheese like some people think. It's actually a big giant rock.
All right. That is so cool. I learned a lot today, Captain Adam. I just realized that flying a plane and putting it in the air needs the balance of all four principles: lift, weight, thrust, and drag.
Excellent, Petrie. You see, you're already there with some of the aeronautical knowledge to get that pilot license. Good job.
Makes me want to be a pilot when I grow up. Wow.
Good luck. Yeah, buddy.
I also learned a lot about different planes that we have and how planes can land on the land, obviously, on water and on a boat.
Yeah.
Plus rockets. Wow.
Yeah.
Oh. Thank you so much, Captain Adam. I really learned a lot from you. And you know what? Time really flies when you're having fun, which I'm having right now.
You stole my joke, Petrie. Thank you, buddy.
All right. Well, bye, Captain Adam. Hope to see you again soon.
Got it.
All right. That was pretty exciting. Flying the sky. Rockets! Well, before I fly away, let's see what Chemistry Kit and Jurassic Jessica are doing right now. To the Petri scope. Beep, 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 boop.
Thanks, Petrie. Wow, that interview was just plain awesome. I learned so much about airplanes and aerodynamics. Didn't you, Jurassic Jessica?
I sure did. I wish we could fly a plane right now.
We can!
Really? A real airplane?
A real paper airplane? Ta-da! Here's a paper airplane that I made earlier today.
Well, let's see it fly.
Alright, here goes nothing. Well, that one didn't fly so well. It wasn't very aerodynamic. I have an idea. Let's have a contest. Let's try our best to make paper airplane that balances the 4 forces of aerodynamics: drag, gravity, thrust, and lift. The airplane that can balance those forces the best will fly the furthest.
Sounds like fun. Let's review those 4 forces of aerodynamics again, though.
Good idea. Drag is resistance to flying through air. Let's do a quick experiment. Hold your hand out in front of you with your thumb on top and your pinky facing the floor. Now swing your arm back and forth. Can you feel the air? That's drag. Now hold your arm out in front of you with your hand parallel to the floor and swing your arm back and forth again. It's like you're slicing through the air. A paper airplane that will fly far should have as little drag as possible. That way it won't slow down in the air.
A plane with as little drag as possible will fly farther. Got it.
Next is gravity. Gravity is what causes weight, and it's a force that tries to pull everything to the ground. Your paper airplane will have to overcome the force of gravity to fly.
That sounds difficult.
The final forces are thrust and lift. Thrust is the forward motion of the airplane. For paper airplanes, the thrust is going to come from the muscles of your arm. In a real airplane, the thrust comes from the engine. Lift is when the air below the airplane wing pushes up harder than the air above it is pushing down. Now, when these 4 forces are balanced, flight can be achieved. Jurassic Jessica, are you ready to make a paper airplane?
Absolutely! Here are 2 pieces of paper. Let's both fold ours and make different types of airplanes, and we'll see who can fly the farthest.
Yeah, let's do it. All right, let's take these outside and test them out. Ready? 1, 2, 3. Yay! Yes!
Having trouble with your ornithopter, Asa?
I'm afraid I don't have all the flight moves. Maybe I should keep it plain and simple.
Plain and simple's right. Let's put this one in the hangar for now. And do some more research on flight and aerodynamics.
I hear the Marion County Public Library System has a great collection.
Do they ever? One of my favorite books is All Kinds of Planes by Carl Johansson. He's a Swedish artist and illustrator, and it's filled with every kind of transportation you can imagine. And it has soaring reviews from Booklist and School Library Journal. Do you have any recommendations?
I love My Dad's a Birdman. It's by David Allman, and it's a wonderful chapter book about a young girl and her dad who's ready to take wing. Perfect for anyone who loves a flight of fancy.
Flights of Fancy. I love Flights of Fancy. And that's why I love The Ultimate Guide to Paper Airplanes. It's by Christopher Harbo, and it offers step-by-step designs that take things to another level. It includes flying tips for all different kinds of fancy paper airplanes.
That's just what I need. Well, you should really check these out. We can't wait to see you next week.
Bye.
Bye.